we are going to go over and start do you guys need to see the problem, or do you guys all have your own copy? Because I can just go straight into the whiteboard. And please ask questions. One second. Okay, so we are going to be looking at a quotient function. So we have to let f of x equal to 2 minus 5 over x plus 2. And then g of x is going to be equal to x over x plus 2 plus x plus 1 over x squared minus 4x minus 12. So my suggestion to you is when you work on a problem like this, you want to go through, and if you can factor, go ahead and factor. That will help you with your lowest common denominators. So x squared minus 4x minus 12, what can we factor that into?
X plus 2, x minus 6.
Okay. Now, if we're looking for the LCD, remember we want to find an LCD that is in common for all the denominators. What's really nice about this one is, what's your denominator for 2?
1.
1. Okay, so you're really only looking at x plus 2, and then x plus 2 times x minus 6. So what do you think your overall LCD is going to be?
X plus 2, x minus 6.
Very good. And then, so now what we have to figure out is our function. So we want to find f over g. So we do 2 minus 5 over x plus 2 over your g. And I'm going to use the factored form so that we can cancel out a little bit easier. Okay. And did it tell us which method? Okay, we're going to solve using method 2, which I believe that was the one where we took the LCD all over the place. Okay, so I'm not even going to rearrange this yet. What I want to do is we're going to see what we need for each piece. So does 2 Does 2 have anything from our LCD? No. So that means we're going to have to multiply it out. So we would have to have the whole thing. So x plus 2, x minus 6. Okay. And then minus, what about 5? Does 5 have any part of the LCD? What part of the LCD does it have?
It has x plus 2.
Okay, so that means we have to multiply it by what's left, which is x minus 6. Okay. Same thing for the denominator. We have x plus 2, so that means x has to multiply by x minus 6. And then x plus 1, well, x plus 1 has both of them, doesn't it? So then we don't have to do anything else now except to make everything nice and neat. Okay. So now we have to simplify. Wish I had more room on this whiteboard. Okay, well, we know what this part simplifies to, right? Because we just took it from here. So if we multiply this out, we get 2x squared minus 8x minus 24. And we'll distribute this piece. So we get minus 5x plus 30. Okay. And if anyone sees a mistake, make sure you say it, because obviously I am human. X squared minus 6x plus x plus 1. Okay. So let's clean this up a little bit. So we have x squared minus 6 plus x will give us minus 5x plus 1. I can tell you that that does not factor. All right. If we clean up here, we still get our 2x squared. Minus 8x and minus 5x will give us a minus 13x. And then 30 minus 24 will give us a plus 6. Now that does factor. It factors into 2x minus 1. And x minus 6. Okay, so this is your overall answer. Now, I would highly suggest that you factor when you can. Now, I noticed on some of your homeworks or quizzes, you guys would factor and then Pearson would mark it wrong. I went through and I did an override of all those kinds of problems. I really actually liked that you guys pulled out when you could pull something out for factoring. It's a really good habit to get into. The only thing I would suggest is if you're pulling something out. So for example, the one thing you guys pulled out was like, let's say it was the letter B. If when you pull that out, it just kind of looks weirder or grosser and doesn't really look like you made it look any more presentable or nicer, you can leave it. You can leave it the way it was prior to you pulling that out. Does that make sense? Okay. You're really only going to pull things out when you can cancel them, or if it makes it look nice and neat, or if the directions say to. If the the directions say to factor, then you definitely factor. But if just because something has an option to pull it all out, you don't always have to do that. But definitely in this case, so if we could have canceled out here, then we would have, but there's just nothing else to cancel out. All right, so the next part of the question was f over g of 4. So we're just gonna take and plug 4 in. Now you could use either approach here. You could use the one up top, this one. Since we didn't cancel anything out, you could use that one as well. But I'm just gonna go from the factored form. And if anyone has any questions, please ask me. Right, once you simplify down, you should get negative 14 over a negative 3, which will just be 14 over 3. Also, not that I can go into too much detail, but I did obviously go through and check your exams. There was a problem that I think I took a half a point off for sign errors. I want to say it was like number 23 or 24. I'm giving you all the half credit back when I put it into tuition. It's just too. I had signs. As long as you had the numbers right and the signs made somewhat sense, I'm giving it all to you because I realized that the signs could really be figured out a few different ways. So I just am giving it to everyone. So this was example 17, and it is the last example in section. Oh, what are you doing? It's the last example in section 8.4. So the next one is going to be starting in 5. So if you're following along with your homework and doing it that way, then you should be able to do up to 8.5 now. And we're going to finish it all today anyway. Anyone have any questions on this one? Okay, I did save it in case you guys need me to upload it later, just let me know. But we're going to move on to example 18. So now we're talking about solving. All right, so we want to solve 2 over p plus 5 equals 8 over p minus 1. And obviously this is the easier question. So what do you guys think? What's the first thing we can do here?
Would you add the one from that side to get it onto the other, or would you not do that with these types of problems?
You could, but before you do that, my first question is going to be, do we like working with fractions?
No.
No. So in general, we don't like working with fractions. So how do you think we can basically undo these fractions? How can we make it so that it's kind of canceled out? How do we do that?
Multiply everything by p.
Very good. And the reason we're multiplying it by p is because that's what the LCD would be. All right, so we're going to get rid of all the p's. So that means we're going to end up with 2 plus 5. But what do we have to put with the 5? It'll be 5 what?
P.
Very good. All right, and then the 8 cancels underneath, so then minus p. And now, Cody, we can bring the variables to the other side. So it's a very, very quick problem, but it does hold a powerful tool because now you all know how to get rid of fractions like that. So p is equal to 1. Now, you can ask some of your peers. I gave credit, not credit, I gave bonus points if people chose to really take the extra step and do their checks. So if you would like me to show you what that looks like. All right, obviously you guys write neater than I do on your exams. So 2 plus 5, does that equal 8 minus 1? So 2 plus 5 is 7, and 8 minus 1. So it is true, it works. There's your check. And that literally got people a bonus point because not a lot of people do the checks. Now, granted, you still got all the credit if you got the problem right. All right, so let's move on to example 19. Anyone have any questions with this question? I'll give you a few seconds. All right, let's move on to 19. All right, so example 19 says to solve again. And we're looking at the problem 2 minus 1 over x minus 2 equals x minus 3 over x minus 2. Now, here's my question to you. What do you have to automatically exclude from your answer?
You have to exclude 2.
Very good. So because we're dealing with fractions, we have to automatically exclude x equal to 2. So that would mean in example 18, we would have to automatically exclude what? If it was just the letter p underneath those fractions, what could we not have as our answer?
0.
The 1?
So 1 would be the understood, and you're allowed to have 1. But yes, it's going to be 0. You don't want p equal to 0 for 18. But we didn't get that, so we didn't have to worry about it. What we would have to worry about here is if we get a 2. So let's go ahead and figure out our LCD. Right, and I think everyone can know at this point that our LCD is going to be x minus 2. All right, so we're going to multiply everything by our LCD. So that just means we get a 2 times x minus 2 minus 1 equals x minus 3. And now you're just going to go through and solve it like normal. So 2x minus 4 minus 1, x minus 3. Bring the x over. We're going to add 5. So x equals 2. So what does that mean? What do you guys think that means? Do we have to do a check in this case?
No?
No, we don't have to do a check in this case because if our automatic exclusion was 2 and our solution is 2, then that means the solution our solution is really the empty set. Okay. Example is the last example before we start getting to application problems. So I'm going to give you guys a few seconds to copy that stuff down, and then I'm going to pull up the chapter 8 notes. Did I already save this one? Yes, I did. Okay. All right, so let's get rid of this one. All right, and now we're going to look at example 20. Okay. Example 20 tells us to evaluate. So it's a little bit different this time. This gives us f of x. So I'm going to let f of x equal x plus 1 over x minus 3 minus x minus 2 x plus 3. And it wants us to find f of x equal to 1. So if f of x is equal to 1, what do you think we have to do? What's the first thing you have to do? We have to figure out where we're putting that 1, right? Where do you guys think we're going to put that 1?
Would it just go into the x value?
So that would be if we needed to find f of 1. This is f of x equal to 1. So where can we put that 1 at then? If that's f of x, and this is f of x.
You make it 1 equals and then the equation.
Very good. Okay. So let's do 2 steps in 1. So we put our 1 in. The next thing we want to do, let's find our LCD over here. What can you guys tell me my LCD is going to be?
X minus 3, X plus 3.
Very good. All right. So now we have to ask ourselves, what is missing? So we have an x minus 3 here, which means to make it no longer a fraction, we have to multiply x plus 1 times what's left, which is x plus 3, minus x minus 2. But it has x plus 3. It's missing the x minus 3. Okay. Oops. Guess we don't need 2 parentheses there. All right. So now let's go through and FOIL twice, and then we will simplify and figure out what to do next. Oh, wait a minute. Did I do it right? Did I make my next step right? What do you guys think? What did we do on the right-hand side? We multiplied top and bottom by what? We multiplied by our LCD, right? To get rid of the fractions? Well, if I do that on the right-hand side of the equation, what do you think I have to do on the left-hand side of the equation? If I want to keep it equivalent, I have to multiply it on the left-hand side too, right? Okay, so essentially 1 is going to be multiplied by your LCD. So x minus 3, x plus 3 equals x plus 1, x plus 3. Okay, and now we can go through and we're actually going to FOIL 3 times. Then we'll simplify. We have x squared minus 3x minus 3x minus 9. X squared plus x plus 3x plus 3 minus, let's keep the minus sign outside for right now. So we'll have x squared minus 2x minus 3x plus 6. All right, so now let's go through and simplify. So our x squareds are going to cancel on this side. I don't want it to be Christmas yet. I'm not going to use red. Okay. Oh, there's the x here. So these cancel. Plus 5x. This is 1x. We simplify everything down, we should end up with x squared minus 9x minus 6 equals 0. Does that look like something you can easily factor? Okay, try it. What's our other approach if you can't factor something? Okay. Assuming that those of you taking notes are following along, so I'm going to clear it so we can have some more room. Problem's not done yet. So let me help you out with this. So let's rewrite this. X squared minus 9x minus 6 equals 0. Do we have a factor of -6 that'll add or subtract to give us -9? Nope. So let me do this so you can have an aha moment. Okay, so what do you think we're going to use? Okay, I'm going to use the quadratic formula. So x equals -9 plus or minus -9 squared minus 4 times a times c all over 2a. That's a 1. Okay. And if you go through and simplify, you're going to end up with x equals 9 plus or minus square root of 105 over 2. If you wanted to give me the decimal version of that, like if you plug all that into your calculator and you end up giving me the decimal version, quadratic formula calculators out there. I don't care if you use them. You just have to show your work like I did. Okay. Because at this point, it's just a tool at this point. So I'm okay if you want to use the calculators. All right, so example 21 is our first of 5 application-based problems. And it is the last one in section 8.6. Okay, so let's clear this. I am going to go over to the PowerPoint for this next example. Maybe, yes. Okay. This is gonna take too long, so I guess. Hey, look at me, I guessed so good. I do recommend that you guys go back as you can to the PowerPoint. Obviously, I recommend you going to the bigger PowerPoint instead of the individual ones because they will match our examples the best. So if you recall, this is the same example that we did earlier in the section. It's the one with the internet users, but now they're having us do a little bit different of a problem. So now they want us to predict when 92% of Americans will use the internet. So before we were plugging numbers into T, but if you're given a percentage, are you going to plug that in for T, which stands for time? Or are you going to plug that in for P of T, which is an actual percentage? Okay, we're going to plug 92 in for the T, or not the T, for the P of T, sorry, excuse me. All right, so I'm okay if you guys actually want to copy it down from the slides. You can also choose to take a photo, or you can go back to the slide if you want. It's slide 132. So if you want to reference slide 132, you can do that. I'm going to give you time to copy that down, and you may ask me any questions if you are confused. Why do you think they're putting in the 92 and not a 0.92? Do you remember what they did way back in the beginning of this problem? They multiplied the right side by 100. So then that means you don't have to convert your percentage. And if you did convert it, you would actually end up getting the problem wrong. Okay, you guys ready for the next one? This is a two-part solution slide. Use the same approach we did in number 20. They went through and they plugged in, they distributed, they multiplied by the LCD, and then they got down to where they plugged it into the quadratic formula. Again, I'm emphasizing, if you would prefer to use a quadratic formula calculator that is readily available for free on the internet, as this is now a tool in your toolbox and not something that I am working on, by all means do that. So once you take a look at these answers, what do you think you can tell me they mean? What does T of 16.98 or T of 991.14, what do you think those two T's represent?
Those are the years since 2000.
Yep.
I didn't figure out what the years would be, but
Very good. So they're actually 2017 and 2991. Obviously, I don't think any of us, probably not even, yep, nope, I don't even know what generation that would be for us. So obviously it's way too far in the future for us to believe anything we would find for that, right? Plus on top of that, COVID, so I'm pretty sure we're not 100% of internet users. I would be slightly shocked if, literally homeless people weren't finding ways to get on the internet at this point. And considering some of them have better phones than I do, they probably have been on the internet for a while. All right, so this is just a recap of the solution. Again, remember, in fact, let me take a quick look here. I have your exam 3 and your final. Exam 3 has 3 application problems on it. So you would need to write statements out for that. And then the final, I'm not gonna add that up yet. I kind of haven't decided what I'm doing with the final. We can keep going if you want. You guys can take notes as you listen to me kind of chit chat. We're almost done. I haven't really decided what I'm going to do with the final. At the moment, my plan is to give you the exam. However, I'm also slightly toying with the idea of I could potentially give you a project out of the textbook. So what I would do is I would so like the trig textbook's really nice because it gives me chapter projects. So I don't even have to think about it. I can just copy and paste and give it to you. I really like having tangible student work. If I were to do that, then I probably would just have you do one or the other, but it would not be optional. So if you didn't do the project, then you would have to do the exam. Does that make sense? Okay. And then if you chose to do the project, which would be heckin' cool, because then I can show what you guys did, then you potentially would not have to do the entirety of the final. I don't know. I have to think about it. Definitely, if you guys have any ideas, shoot me an email. If you would prefer a project over the final, you could do that. You can let me know. If you would like to see what some of the projects would look like, you can let me know that too. If you would like to maybe potentially have a project as extra credit, I might be willing to get talked into something like that as well. And if I did that, I would probably do it so that, let's say you had a really crappy exam score, it would probably boost that exam score to not so crappy. We have, I believe, a month roughly. We still have one more chapter to cover. We still have one more exam to prepare for and take. And then we would just have the final or the project or some combination thereof. So definitely let me know what your thoughts and feelings are. I will try to take it into consideration as much as possible. I don't believe I've given this final in the past because spring, obviously COVID hit, and then the summer, I just felt like the classes were too small, like not enough time. So I don't think I gave it then either, but I would totally be okay with the project, I think. So I don't know, like I said, give me your ideas, either via email or at some point here soon. And I can definitely send you project ideas if you would like to see those before you make your decision. All right, so what we're gonna work on next is called direct variation. And there's also indirect variation. I think you guys have heard me say this before. I'm super duper dyslexic, so this is definitely one of the areas that drives me crazy. But if you take your time and really read what the question is asking you, and also obviously you're online and I'm okay with you having examples in front of you. If you have a direct variation example in front of you, use the direct variation example, okay? So basically what we have to find is what's called the constant of proportionality. Pretty much to do that, they give us an X and a Y value. This is basic. This ends up being a question, I think, on Pearson, potentially. But it kind of just breaks it down for you a little bit more. If you have a direct correlation, if you have a direct variation, then if X increases, Y is obviously going to increase. If X decreases, Y would decrease. So then what would the opposite be for that? If you have an inverse variation, which we're going to get to next, those would just flip-flop, right? Okay, don't worry about it right now because we're going to go to the next example. But okay, so here's your question. We have to find the variable y varies directly as x with a positive variation constant k. So our two situations here is what happens to the value of y as the value of x increases. Well, that was on the last slide. What happens?
It's increasing.
Yeah. Okay, so if x increases, y increases. So now let's put that theory to test. If y equals 5 when x equals 3, they want us to find an equation for x and y. Okay, so how do you think we would set this up? Let's look back at the equation. It was y equals kx. Well, we have y equals 5 and x equals 3. So let's just do it right here on the slide. So y equals kx. So that means you're just going to plug in. So 5 equals k times 3. Well, that just means that k equals what? K is going to equal 5 over 3. But that's not what the question asked, right? The question wanted to know what's an equation involving x and y? Okay, well, now that we have k, well, we can just work backwards a little bit. Y equals 5/3 x. Do you agree or disagree? If you really wanted to check this, you could, let's get rid of these so we can move on. If you really wanted to check this, we could put it on a graphing calculator. You could use Desmos, you could use Desmos, regular calculator, anything else. You could technically, since it's a linear equation, you could graph it by hand, and you're looking for the 0.35. If the 0.35 lies on this line, then you know you did the problem right. All right. So this next problem is an application. Okay, it's an application-based problem. We have to assume the bounce height b in inches of a tennis ball varies directly as the drop height b in inches. The bounce height of the tennis ball is 20 inches when the ball is dropped from an initial height of 30 inches. So the first thing they want us to do is they want us to figure out an equation for b and d. Well, if it varies directly, what basic equation are we looking at there? What equation do we want to use if it varies directly? We're going to have b equals k times d. Okay. So if I wasn't here to tell you that equation, how would you know which variable to put in for x and which variable to put in for y? If that's the problem you had, how would you know which goes where? This is how you want to read it. It always goes y varies directly with x. Okay. Don't ask me why that is. Some old dead white guys decided it, but that's just the way it works. Okay. If you try to do it any other way, you're going to end up with the wrong answer. So, all right, so let's plug some things in so we can find what our k is equal to. So we end up having 20 equals k times 30, which means k is equal to 2/3, because the zeros cancel out, right? And then for some reason, and I really can tell you that I really would prefer they didn't do it this way, but it's the way they're doing it. They go ahead and they use the decimal representation. I would be perfectly fine if you left it as the fraction, but we'll just stay consistent with the slides. Okay, so there's your equation. Now it wants to know, estimate the bounce height if the drop height is 50 inches. So we're just going to plug 50 in for D. Okay, so 0.67 times 50 equals approximately 33.5 inches. Okay. And we will save that slide. Okay. And we can run through these real quick. I'll show you the slides for them real quick. Okay. There's showing you that I did not lead you astray for the equation. There's your solution. Now here, of course, the bounce height will be 33 inches according to the model, or you could say according to the model, the bounce height will be 33.5 inches. I don't care how you sum it up, but when it comes to application-based problems, I really want to see that statement, okay? I want to see that you've taken it seriously, and that if I send you off into the world and you're in a employment situation and your boss wants you to do an application-based problem, you're not just going to write on a scrap sheet of paper, here it is, 56.5 boxes. Like, when you're in a work environment, bosses want a little bit more effort than just the answer. Okay, sometimes they prefer if you just give them just the answer and they don't care about the fluff. But if you really want that promotion, you'll give them all the fluff. Okay. All right. Inverse variation. Go ahead and take these notes down. You can see kind of why my dyslexia pops in here, right? Because they're pretty close. They're just a little different. Okay, let's wrap this section up. All right, so again, this is just telling you kind of in words what that mathy definition told you. In this case, because we're looking at inverse variation, if x increases, then y will decrease. And then if x decreases, then y will increase. Okay. All right. Here's our example. So for positive values of x, what happens to the value of y as x increases if we're talking about inverse variation? What's going to happen there?
It's going to decrease since it's the opposite.
Yes, y will decrease. All right. Next thing we want to do is we want to find our equation for x and y. So we have y equals k over x. And we're given 4 for y and 2 for x. So then k equals 8. So then our equation should be y equals 8 over x. Okay, we'll save that. Oops, oops. Apparently you have to clear that. That's annoying. Clear. All right. All right, so there's your solution for A. We were right. Y must decrease if x increases. Here's your solution for B. Again, we were right. Y equals 8 over x. Okay. Now, I don't really consider these smaller ones application problems, so you don't really have to give me a whole sentence here that the equation is y equals 8 over x. The ones I obviously consider a solution or an application will be the ones like this, okay? All right. If you want to verify, you're looking for the 0.24. Okay. And again, you could choose to draw this by hand. You can use Desmos. You can use your graphing calculator, but you would check for the 0.24. And you guys will get this as you practice more. Okay. Finding and using an inverse variation model. I don't even know why they're really showing it, except that P and T can be used interchangeably with X and Y. Okay. All right. So last example says the weight of an object varies inversely as the square of its distance from the center of the Earth. An astronaut weighs 180 pounds at sea level, about 4,000 miles from Earth's center. How much does the astronaut weigh 2,000 miles above the Earth's center? So first, let's take a look at this drawn out. Okay. So we're going to let W be the weight in pounds of the astronaut, D thousands of miles from the center of the Earth. Our desired model would be W equals K over D squared. The denominator of the fraction on the right-hand side is D squared because weight varies inversely as the square of distance D. Okay? So you really have to pay attention to how they give you the information. What they had given us was that the astronaut weighed 180 pounds. Okay, so he weighed 180 pounds. when he was at sea level. Sea level is equal to 4,000 miles above or away from the center of the Earth. So that means we have to take 180 and multiply it by 16 to get our K. So somebody tell me what K is.
$2,880.
Mm-hmm. Okay. And then the question was, so now if we rewrote this, we would have W equals 2,880 divided by D squared. And the question was, what happens when the astronaut is an additional 2,000 miles above the Earth? Well, that would give us a total of 6,000 miles from the center, right? 4,000 and another 2,000 will give us 6,000. But D is in thousand of miles, so we only have to worry about 6. So we're going to take 2,880 and we're going to divide it by 6 squared. Okay, so 2,880 divided by 36 will give us what?
$80.
Yes. Yes, so W would be 80, which means if we wrote it as a sentence, which I guess I can use the text to do that. So the astronaut weighs 80 pounds, 2,000 miles above Earth. Okay. So if you're dealing with an application-based problem, what's the solution? I want you to give me a sentence. I have all of my work on scratch paper. If you guys really think you need it, shoot me an email. I'll put it up on Canvas if you really think it's needed. If not, I'll just hold on to it. Oops. Forgot to clear it. Right. So we'll just go through and verify. There's our equation. There's the nice little diagram that I wanted you guys to see before I went through and answered the problem. I just forgot which slide it was on. It's still good. I will definitely give you a bonus point if you give me a diagram. Now, I'm not saying if the problem doesn't need a diagram that I'm going to give you a bonus point if you feel like drawing me little diagrams. But if the problem actually would benefit you to have a diagram, I will give you the bonus point. Okay, so that is the end of the slides. Don't go anywhere because I am going to take attendance real quick.